Noticed a very common misconception came up in class, so I just wanted to spend a minute or two talking about it. So in class we had a situation where we had a plane and a point on the plane. So let's call this point 1, 2, 3, and we'll call it point P. Question is the vector 1, 2, 3 on the plane? The vector represented by what we'd see as the coordinates to P. And so in order to answer this question, we might ask ourselves exactly what is that vector 1, 2, 3? Well, if we drew it out, that vector 1, 2, 3 would be from the origin to the point 1, 2, 3. So in other words, the vector is OP, where O is the origin. So you might ask yourself, well, is OP on the plane, the vector 1, 2, 3? And you can see from the graph here, it's pretty clear that the vector OP is not on the plane because the origin is not on the plane. Suppose we had another point. Let's call this point Q, 105. Question is 105 the vector 105 on the plane? And again, we can draw the vector OQ, which is the vector 105. And you can see because the origin is not on this plane, the vector 105 is not on the plane. So we have for both of these points, OP and OQ are not on the plane. The point 105 and the point 123 are both on the plane, but the vector 105 and the vector 123 are not on the plane. So what is on the plane? Well, if you have 2 points on the plane, we can draw the vector between them. So here's the vector PQ. And you can see, well, the vector PQ, its endpoint and starting point, the head and the tail of this vector, are both on the plane. So the vector PQ is on the plane. So the distinction here is important. The point 1, 2, 3 is on the plane, but the vector 1, 2, 3 is not on the plane. The point 105 is on the plane, but the vector 105 is not on the plane because the origin, the other point for these vectors, is not on the plane. However, the vector with both points on the plane, both the tail and the head, that's the vector PQ. That vector is on the plane.